Tutorial for the homework assignment that is on page 83. That would be page 83 numbers 1 through 8, 19, 27, and it finishes up with number 45. Okay, getting started, before I even talk about some of these exercises, what I want to do is I just want to recap what we mean by multiplication. You might be saying, multiplication, but we're supposed to be doing division, and you're right, okay? But here's the thing, multiplication and division are opposites of each other. So if we can consider one, the other one will actually make sense by looking at it as it being opposed to the one that we know very well, which is multiplication. Okay, so I'll have you look over here. I've written multiplication and division. You can ignore the division for now, but look at these multiplication sentences here, and let's really break down what multiplication means. In a very, very rigorous and mathematical sense, multiplication does represent repeated addition, but in a practical sense, we usually think of it as saying, okay, for example, 2 times 4 equals 8. Remember, 4 times 2 equals 8. Here's kind of what we're saying. We're saying, okay, I have 2 groups of 4 in each group. How many would I have total? So 2 groups of 4 would give us 8. Conversely, we'd say, okay, I have 4 groups, and there are 2 in each group. I have 4 groups of 2. This also gives me 8. The interesting thing here is that multiplication is commutative. In other words, it doesn't matter what order you multiply in, you would still have the same total amount. Now, division being the opposite of multiplication, we can actually work backwards. So, like, for example, if I said, hey, what can I take times 2 to get 8? We could work backwards by using the opposite or the inverse operation. So what I'm saying here is we'd say 8 divided by 2. But in a practical sense, this would be like saying, okay, we have 8 of something, and we want to split it into 2 groups. How many would be in each group? Okay? So this is what I've illustrated down here, which is the backwards representation of these multiplication sentences. But it'd be kind of like saying this, okay, this is what we have. And what I need you to realize is whenever we write a division sentence, the first number in the division sentence, which is the dividend, the thing being divided, is always representing what we have. Now the second number is kind of saying, okay, I have 8 of something, and I want to split it into groups of this size. How many groups could I make? Well, I could make 2 groups if I were making them into groups of 4. On the other hand, we could look at it another way and say, okay, you know, if I took 8 and I wanted to split it into 4 different groups, it would be groups of this size. So one more time, I'll run through it. Okay, I have 8. I want to split it into 4 equal-sized groups. There are 2 in each group. The other way of thinking about it is this. Okay, I have 8 of something. I want to split it into groups of 4. I would have 2 groups of that size. Same thing down here. I have 8 of something. I want to split it into 2 groups. There's 4 in each group. Hey, or I have 8 of something, and I want to split it into groups of this size. I would have this many groups of that size. Now that being said, finally we can look at number 1. Now number 1, if you've read the book, and I have the book right here, it talks about a home ec class, and they're making muffins. Now here's the deal. It says they have a bag of sugar, and they want to know how many muffins you can make with this bag of sugar, considering the fact that you only need 1/4 cup of sugar for each muffin. Now here's what I need you to think of. It says in the book that there are 20 total cups of sugar. What I've done here is drawn a box, and what this is going to do is going to illustrate just one of those cups. 1 cup, okay? We'll talk about 1 cup, but then put it in the context of what if I had 20 cups, okay? But here's the neat thing about it. It says it takes me only 1/4 of a cup to make a muffin. So how many muffins could you make? Let's consider 1 cup, okay? With this 1 cup, I know that if I split it into 4 equal-sized pieces, okay, each one of these represents 1/4 of a cup, or what I would need to make a muffin. In other words, 1 cup of sugar would be able to produce 4 muffins, since each muffin only needs 1 of these 4ths. Okay? Now, if I were to write this as a division sentence, which is what I'm trying to push us towards, it would be this. Well, think about it this way. I have 1 cup could make 4 muffins. So if I have 20 cups, that'd be like 20 times 4, that'd be 80 muffins. Here's how I'm coming up with this. I'm really saying I have 20 cups. Because remember, division, this is saying this is what I have. I have 20 cups, and I want to divide that up or split it up into groups of 1/4. Now, we've said practically, if each 1 cup makes 4 muffins, then 20 cups would make 20 times as much. 20 times 4 is 80. So here's the deal. This division sentence is completed by writing this 80 here, okay? So basically what we're saying is 1/4 would fit into 20 holes 80 times. I mean, that's a lot of muffins. And it makes sense here, okay? Now moving on, number 2, it says, okay. you know what, it's not 1/4 of a cup of sugar anymore to make the muffins. We don't need them to be that sweet, so maybe we only need 1/8 of a cup to make a muffin. Let's pretend this is 1 cup of sugar. Now remember, I know that we have 20 total cups, but let's just look at one of these cups. If I were to split it into 8s, I know each one of these 8 cups makes a muffin. So we say, okay, well, how many muffins could you make if you had just 1 cup? Well, I could make 8 muffins because each 1/8 makes a muffin. But I have 20 cups. Okay, so that'd be 20 times as many because each cup makes 8 muffins. I have 20 of those cups. 20 times 8 is 160. Modeling this, however, with the division sentence, it would look like this. I have 20 cups of something. I want to split it into groups of this size. How many groups of this size could I make? And we said practically we could make 160 muffins. Now you might start to think, okay, where am I getting these numbers from? What could you do with like this number and this number to make an 80? Well, I'll tell you what, I look at this and I say 20 times 4, that would give me 80. Here's the point. When we are dividing with fractions, we are technically turning it into multiplication by the reciprocal of this second number. What I'm telling you is, any division sentence can be turned into multiplication so long as you take the second number, or the number you're dividing by, and flipping it. That's it. Hey, if I were to complete this multiplication sentence, it would look like this. Hey, 20 times 4 is 80. 1 times 1 is 1. This is not crazy. Same thing over here. Hey, 20 divided by 1 over 8 is the same thing as 20 times 8 over 1. Oh, okay. Yeah, 20 times 8 is 160. 1 times 1 is 1. So here's the deal. When you divide with fractions, you just multiply by the reciprocal. It's great because we know how to multiply really well. Hey, that being said, number 19 asks an interesting question. It says, okay, Bill wants to make 22 small pizzas for a party. Now, they're trying to throw you off with this number. Let's just keep reading. It says, okay, but he has 16 cups of flour. This is what he has, okay, and 3/4 cup of flour is needed to make each crust. Can he make all 22? Let's find out how many he could make. Here's what I know. He has 16 cups of flour, and he wants to split it up into groups of this size. How many groups could he make? And using what we already know about dividing with fractions, like I said, this is like the 4th time I've said it. When you divide by a fraction, it's the same as multiplying by the reciprocal. You flip these. You say, okay, 4/3. Well, you know, that's a whole number, but to solve this problem, we'll just make it into a fraction and multiply. Here's what I know, and I'll throw you a bone here, but 16 times 4 is so totally 64, and 1 times 3 is 3. Now, you might be saying, okay, that's interesting. That's interesting. That's how many groups I can make. I can make 64/3 groups. That sounds weird. We need to simplify this. So the question now is, how many times does 3 go into this evenly, and how many would be left over? Okay, so here's what I know. Putting 64 on the inside of this box, because we're dividing it by 3. 3 goes into 6 twice. 2 times 3 is 6. 6 minus 6 is 0. We'll carry it on the 4 and go again. I know that 3 goes into 4. Uno tiempo, okay? And I say minus 3. Here's the deal. There's 1 left over. I'm going to circle it because I don't need a decimal here. Here's what I wanted to find out. Okay? This would be 21 and 1/3 left over. 21 and 1/3. Now that's how many he can make. But he was supposed to make 22. So, hey, can he make it? Obviously, apparently, he cannot on this problem, unfortunately for him. So, okay, moving on. The last one I wanted to talk about was number 45. Now, this is interesting. It is talking about multiplication. But specifically, hey, what could you take times a number to get a product? Remember, product's an answer to a multiply problem. A product of 1. Okay, that's what we want. And the interesting thing about math is, when you multiply something by its reciprocal, you get a product of 1. Matter of fact, I think it'd be easier to start with B here. I'm saying, what in the world could I take times 1/2 to get it to just be 1? Well, hey, here's what I do know. 2 halves would equal 1 whole. So let's just take this times 2. Let's double it. But here's the point. If I were to write this whole number as a fraction, you notice that these two fractions compare to each other because they're reciprocals. All right? So I say, all right, 1 times 2 is 2. 2 times 1 is 2. 2/2 is 1. So you might say, okay, what's the reciprocal of 2 then, Mr. A? I have no idea. It's not even a fraction. How am I supposed to flip that? Well, hey, don't be lazy. Turn it into a fraction. Oh, hey, turn those numbers around. What do you get? 1/2. Wait, what do you notice about these two problems? They're the same thing, okay? So for the 5th or 6th or 7th or millionth time I've said it probably to you this week, when you divide with fractions, you multiply by the reciprocal, which means, hey, take your division problem, rewrite it as times the flippy thing of the other number, and then just go ahead and proceed. Good luck with the homework.